Structural Engineering. Learn it, try it. By Tammy Enns. Chapter 1. What is structural engineering? Have you ever traveled in a tunnel through a mountain or under city streets? Have you ever gazed at a skyscraper swaying in the wind? Have you peered over the edge of a bridge? Then you've taken a look at structural engineering. A structure is anything designed to resist or support a force or load. Structural engineers usually design buildings and bridges. They also work on projects such as airplane bodies and equipment supports. Structural engineering is an ancient science. Age-old builders may not have had today's methods to calculate forces and test materials, but they understood the concepts. The results of their understanding are seen in ancient pyramids and arched bridges. Many are still standing after thousands of years. Structural loads. All structures must hold loads. There are two types of loads: dead loads and live loads. Dead loads include a structure's own weight and everything attached to it. Windows and walls are part of a dead load. The dead loads on a structure remain the same. Structures also carry live loads. These loads are the people and other things that move in and out of a structure. Engineers calculate live loads based on how a structure is used. Buildings used for libraries will hold heavy book stacks. Warehouses hold hefty boxes. Schools and theaters have many people moving through them. Live loads will be different in each of these cases. Live loads also include forces from nature. It matters if a structure is built in the snowy Scottish Highlands or on a sunny Florida beach. Location influences the engineer's design. Structures in cold regions must hold up to heavy piles of drifting snow. Structures in earthquake zones must resist earth tremors, and all buildings must be designed to resist gusts of wind that push on them. Fact: hurricanes are huge forces of destruction. They can slam structures with wind speeds of more than 157 miles, 252 kilometers. Chapter 3. Bridges. Bridges are impressive structures. They do more than carry traffic. They often define a landscape. The Golden Gate Bridge in San Francisco is a well-known symbol of America's West Coast. The Tower Bridge in London is one of the most visited sites in Europe. These bridges are beautiful. They're also excellent displays of structural engineering. Each footings. Soil strength determines the foundation type. Foundations are usually made from concrete. Concrete is strong. It is easy to place under structures. It also provides a heavy base for a building. Concrete footings support many buildings. Footings are slabs that are larger than the column or wall placed on them. Chapter 5. Horizontal Systems. Sometimes structures have pieces that seem to go every which way. They may look like their design doesn't make sense. However, each piece is part of a system, and each system is designed for a special purpose. The horizontal structure system is the first system that engineers think about. It supports roofs and floors. It carries their weight to the vertical system. Then the vertical system connects to the foundation. Beams and joists. The main horizontal structural pieces are beams and joists. Beams are usually solid pieces of steel, wood, or concrete. Joists are made from smaller. Chapter 6. Vertical Systems. A vertical system brings loads from the horizontal system to the foundation. Walls and columns are parts of vertical systems. Columns are solid pieces of steel, concrete, or wood. They go from floor to floor. Columns attach to beams at each level. They are. Chapter 7. Lateral Systems. Is it possible to feel seasick hundreds of feet in the air? That's what some people feel like in very tall skyscrapers. These buildings can sway several feet in strong winds. Wind forces are planned for when engineers design buildings. So are earthquake tremors. Both forces can sway or shake a building side to side. These sideways loads are called lateral loads. Each structure must have a system for resisting lateral loads. The Taipei 101 Mass Damper. Taipei 101 in Taiwan is one of the tallest buildings in the world. Between its 87th and 92nd floor, a 728-ton, 660 metric ton globe hangs. This giant mass damper sways back and forth up to 3 feet, 1 meter. It stabilizes the building during typhoon gusts and earthquake tremors.